MongoDB provides two logging facilities for tracking activities on your database. The process log displays activity on the MongoDB instance. The process log collects activity into one of the following components. Each of these components has an associated verbosity level. You can use db.getLog components in the Mongo shell to review the currently configured log component verbosity. Let's take a look. I'm connected to the MongoDB server using the Mongo shell. I can run db.getLog components to retrieve the log components from my current database. So what does all of this mean? Starting at the top, the verbosity field is the default verbosity level for the MongoDB server. Any of the other components can inherit from this field. See how all of these other components have -1 as their verbosity? -1 means inherit from parent. You can see I have a verbosity of 1, so all of my components are inheriting from that. Log levels 1 through 5 just increase the verbosity level to include debug messages. The higher the number, the more verbose your debug messages are. Let's just recap that very briefly. -1 means that the log component inherits its verbosity level from its parent. By default, your verbosity is typically 0. That means informational messages only. I had set my verbosity level to 1 so I could see more debug messages. A higher verbosity level means more detailed and more frequent debug messages. If you're not trying to actively identify and resolve an issue, you can leave the verbosity at 0 for a base level of monitoring. You'll notice that for some of these log components, there are actually subcomponents as well. Remember there were 3 different components for replication? You had your standard replication component, and then you had a heartbeats and a rollback component. You can see all 3 of them here under the replication parent. Each one is inheriting. Heartbeats and rollback both inherit from replication, which itself inherits from my top-level verbosity field. Now, how does all this work? There are 2 ways that we can look at the logs. The first is by using the getLogs database command here in the Mongo shell. The other is to use a utility like tail-f to follow the end of the log. Let's start with the getLogs command. I'm using db.admin command because getlog has to be run against the admin database. I'm specifying global to tell getlog to give me all of the log activity. This is going to return the entire log up to the point we ran this command. You can see that I have a lot of index activity. There are several commands in here, including the command I ran when I ran db.getLog. Looking at this, I actually have a little bit too much index activity. I don't really need this level of detail. Let's change the log verbosity for the index component back down to 0. I'm specifying the verbosity level that I want to change the component to with db.setLogLevel. The output here is what the log level configuration was. I can rerun db.getLog components to see my updated value of index. We can see here that I've successfully set the verbosity level of the index logging component to 0. Let's take another look at the log, this time using tail-f. I'm specifying the path to my log file to the tail utility, and I'm specifying the -f flag to direct tail to follow this log. That means that I will constantly get updates as there is new activity posted to this file. Depending on your operating system, there may be different utilities from tail available to you that perform the same basic function. Let's specifically take a look at this command logging event. So this is the command that I just identified in the log file. Let's start with the timestamp. This lets us know when the event occurred. Next, I have the severity level of the message. Briefly, there are 5 types of severity levels. You have fatal, error, warning, informational, which is related to verbosity level 0, and debug, which is related to verbosity level 1 through 5. This component has a verbosity level of I, which means that this is an informational message. Next, we have the actual log component that the operation falls under. In this case, the operation is a command. We can also see the connection that the event occurred on. Connections are incremented and unique, so any events initiated by a specific connection are likely from the same client. We have more specific information on the event. We have a command action that was executed on the admin database. The $CMD indicates that this was a database command. The full list of possible events and descriptors are out of scope, but in general you can expect that what immediately follows the connection to be the operation that triggered the event. App name indicates what client initiated the operation, in this case, the Mongo shell. Now we can dig into the command itself. The entire document is the skeleton of the command executed. Under the hood, we have a setParameter command that sets the log component verbosity of the index log component on the admin database. The command was spawned by me using the db.setLogLevel method. Finally, we have some metadata related to how the operation performed. The last data point is of particular interest. It's how long this operation took to complete. We will talk in another lesson about slow operations and how to identify them. The MongoDB process log supports multiple components for controlling granularity of events captured. You can retrieve the log from the Mongo shell or by using command line utilities like tail. Finally, you can change the verbosity of any log component using the Mongo shell.